A warm welcome to all. This is Vigneshwari and then AP is Department of ECE, Mahindra Engineering College for Women. Today we discuss about the topic of PM junction. Before that, we should know about the semiconductor devices. Normally, the material can categorize as three categories. One is a conductor, semiconductor, and a insulator. Here, when we see these three categories, why we choosing this semiconductor means it only having the energy band gap of 1.1 electron volt. That is the energy, the range between the valence band to conduction band is to 1.1 electron volt. That why we choosing the semiconductor. So semiconductor is biasing between either it to be conductor or insulator. So under to that we can discuss about the PM junctions. That semiconductor can categorize as two categories. One is a P type, another one is a N type. P type means that is covalent bond with our trivalent, and then N type material is doping with our pentavalent. Here we combining together P and N, commonly we known as a PM junctions. From that P-type material having the positively charged element, that is named as a holes. N-type material is negatively charged element, that is named as a electrons. So next one, we have to move on the unbiased PM junctions. So when we connecting the P and N, here already we told P having the positively charged element named as a holes, N having the negatively charged element as a electron, and then when it move from the hole will trap from P to N, vice versa the electron will trap from N to P, the current will be constituted. So at that time, whenever the hole will move from P to N, it leaving the negatively charged element near the junction. As a vice versa, when electron from N type move from N to P, that time the electron will leaving the positively charged immobile ions around the junction. It will reduce the charges current. So this region is called as a depletion region. Near this depletion region, two forms the immobile ions, electron and then holes around that. So overcome that depletion region as well as increase the current conductivity, move on to the biasing. So we having the two types of biasing. One is forward bias, another one is a reverse bias. So first we discuss about the forward bias. Forward bias means already we know about that we forming the PN junction by connecting the P-type material and then N-type material joined together. Forward bias means P-type is connected to the positively terminal battery and then N-type is connected to the negative of battery. So P-type having the positively charged element holes and then N-type having the negatively charged elements electron. So already we know about that when the hole will move from one junction to another junctions, it will leaving the immobile ions. Here also same thing. When electron will move from this region to N to P, it will create the immobile positively charged element near the junctions. When we apply the supply voltage, if you taking a silicon means 0.7 electron volt and then germanium means 0.3 electron volt. When we apply the supply voltage crossing the 0.7, it will automatically reduce the depletion region width. So as the same time the hole will move from P to N and then electron will move from N to P. The depletion region will be reduced. At the same time electron and hole recombine together and it constitutes the current. Here the majority charge carrier, due to the majority charge carrier only, we can forming a current. And then next we move on to the reverse bias. So as the same thing P and N type, here p-type material, positively charged element, holes will be connected to the battery of negative, and the n-type material, electron to be connected to the positively charged of battery. So when we apply a voltage 0.7, the electron will the electron will not